Welcome back to the Quantum Yoga Podcast. We've got David Lesondak on the program today. He's got a whole bunch of letters after his name, and if we need to go into what those all mean, we can. But a brief bio of David's. He's a member of Allied Health Professional Staff at the Department of Family and Community Medicine at the University of Pittsburgh Medical Center. He's a structural integrator and fascia specialist at UPMC Center for Integrative Medicine, specializes in chronic pain, pre- and post-surgical issues, physical performance enhancement, and treatment for those suffering from cancer. Since 2010, David has been the chief video documentarian for the University of Ulm's Fascia Summer School. He lectures and teaches internationally. He's the author of this fantastic book, which we'll be talking about today, The Fascia, What It Is and Why It Matters. It's a great book. I use this all the time. Welcome, David, to the program. It's great to have you.
Thank you, Jonathan. Thanks for inviting me on.
Maybe we could start with just a brief intro to your history in the world of fascia. Mm-hmm. Can you tell us a little bit about how you got into it and the way you navigated that path up to this point?
Well, it was brief that's the key word here. So I had been a clinically oriented body worker for 8 or 10 years. Started developing some repetitive movement problems of my own. Had a brief introduction to fascia and fascia work in my clinical training, but it hadn't really clicked until I met somebody who did fascia-oriented bodywork. And then there was this trifecta, hat trick for you hockey fans, of, oh, this is exactly what my body needs. I have to learn how to do this as fast as possible. And I think I'm actually kind of doing this, but I didn't know this was what I was doing. So I better learn more about it. And that would have been around 2000, 2001 in there. And what I mean by, oh, I was already doing it, is there is a particular end feel as a practitioner when you're working with fascia. And there's also a particular effect that it has on the person on the table. So it doesn't feel like typical neuromuscular work or trigger point work or PNF or other things like that to the person and to the practitioner. So when I had this work done on me, I recognized that feeling. And the fact that I realized, oh, this is what I'm doing, explained to me also why when people would come back and they'd say, oh, do that thing you did again last time. That was amazing. And it wasn't as amazing the second time around because we'd already done that. Mm-hmm. And anybody who works with fascia realizes that it's a continuum and it's a process. It's not like, oh, I have a stuck piece of fascia. Thank you for releasing it. Now I can go back to my tennis game. It's, oh, that stuck piece of fascia results in a compensation up the arm and into the deltoid and maybe into the neck in the way I turn to the left. Blah, 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 blah. There's a pathology to it. So until you understand how the fascia really does connect everything to everything else and how those linkages and relationships work, then you realize that working with it is a progressive situation, not a lather, rinse, repeat, if you get what I mean.
Yeah. Well, give us an introduction to fascia. What is, so for someone who maybe just has heard the word but doesn't really know what it is and what it looks like and what it's comprised of, how can you introduce that?
Okay. Fascia is your soft skeleton. So if you think of your bones as your hard skeleton, if you stacked your bones one on top the other, they wouldn't have stability. Your fascia is what gives the bones stability. But it doesn't just wrap every bone and every muscle. It wraps every organ and every nerve. It interpenetrates every muscle, every bone, every organ, and every nerve. And its thickenings comprise other structures that we call tendons and ligaments. It has both a solid nature and a fluid nature. Obviously, in a tendon, the solid nature, it's still very fluid, that tendon. But by comparison to, say, the fascial wrapping of a muscle, that tendon has much more collagen in it to give it greater stability as well as a degree of flexibility. So that's the crazy thing about fascia, and that's the thing that makes it, has made it, I think, an outlier in Western medicine for a while, is the fact that it's not just a tissue, it's also a system. And as a tissue, it's both fluid and fiber. So it's not an either or proposition. And in medicine, and I also think as a culture, we've become very indoctrinated into either or propositions. So either you're with us or you're against us. Either you're red or you're blue. Either it's broken or it's fine. And there's a lot of in-between states. What I always tell people is that fascia work is for when you're stuck. So you go to the doctor, you go to the orthopedist, you go to your yoga teacher, whomever, and it's like, well, it's not broken and it's not worn out. It's just kind of stuck. What do you do when you're stuck? And that's when you go to somebody who treats fascia.
Got it. You mentioned collagen, and I was fascinated to read in your book that there are now, what, 15, 17 different identified types of collagen?
Mm-hmm.
And that, but
I don't know them all.
Well, it's a fascinating amount. I mean, it's like keeps growing, it seems. And, but there is a primary one that makes up most of this network. Is that true?
Yes, that's predominantly collagen type 1, though women tend to have more collagen type 3 than men. That's partially what makes them more flexible. And the cells responsible for producing collagen have sex hormone receptors. So during pregnancy, during menstruation, those stretch hormone receptors receive more signals from estrogen and several other sex hormones. So actually, during those times of life, the cells that produce the more stabilizing collagen produce more of the type 3 elastic collagen.
Wow. So does that mean that, okay, so does that mean then that sex hormone, the amount of sex hormones and the different kinds is determining the tensional nature of the network?
I wouldn't say it's determining, but it's having an effect on it. Absolutely.
So the more testosterone one has and the lesser amount of estrogen one has, generally that's going to make the system tighter.
I don't know that that's a fair go-to. What we do know is that there are sex hormone receptors on the fibroblasts, which are the cells that produce collagen or eat away collagen, depending on the signal that they get. And those little sex hormone receptors, which are like little antennas listening to the environment around the cell, can respond to estrogen, and I'm just blanking on the other two sex hormones that they respond to. And you could take
progesterone, maybe?
No, it wasn't that one, I don't think. But I can take a second here and look it up. But that's not necessarily, that doesn't mean that if you have a lot of testosterone that I don't know that these cells have testosterone receptors. Mm-hmm. So that's why I'm saying I wouldn't say that that's a fair equivalency. But what it does point to is that that women tend to be more flexible in some ways, partially because they have more of the type 3 collagen, but also postmenopausal, they're not getting those sex hormone receptor messages. So they do tend, there is the concern that postmenopause, that there is going to be more of the denser collagen and less of the elastic collagen, which might indicate why sometimes they might need more work. Okay, estrogen, relaxin, and estradiol. I can never say that.
Yeah, okay.
Yeah, so that's what it is. Estrogen, relaxin, estradiol. Okay, those are the three that we know about.
That's so wild. I mean, the reason I'm asking about testosterone is because at least in males, there is almost an inverse relationship between testosterone and estradiol, and that and if aromatase is happening, you're converting a lot to estradiol, you're converting a lot of that testosterone. So it's almost, I would wonder if there was some kind of correlation study that one could look at between range of motion movement and the amount of estradiol in a male, for example, and to see if there was some kind of if you could even do that, if you could even establish controls for that.
So what's the phase that's converting the testosterone to estradiol?
Aromatase. It's an enzyme.
Right. So what is producing the aromatase?
It's some enzyme. So aromatase is an enzyme that's converting testosterone to estradiol.
Right. But what makes it do that?
Well, it could be a few different factors. It's a big question mark. Not everybody, it's not well known why this is happening, but there are certain environmental toxins that can do that.
Ah, okay.
They're like, there are xenoestrogens in the environment, like BPA in plastic, and that kind of thing can do that. Sometimes metals can do that. Certain kind of heavy metals can do that. Sometimes stress can even do that.
Oh, yeah. Okay. Well, if you want, after the program, I'll give you Carla Stecco's email address, because she's the one doing the study on sex hormones, but her interest is in the female of the species, which I can understand.
Wow.
But that's
okay.
an interesting question. That's a really interesting question.
So, okay, so we have this substance that is, you're saying, fiber and water.
Mm-hmm.
And it's just,
not water like this water.
Tell us some more about the water.
Okay, so the fluid content of fascia is predominantly proteins in sugars in a semi-fluid slurry. Say that 3 times fast. Semi-fluid slurry. That also work as a transport for chemical facilities, for metabolic pathways, basically for the fluid flow, for the intra and extracellular fluid, the extracellular fluid flow throughout the entire body. You've got about 15 liters, I think it is, of extracellular fluid in your body, and that's what we mean by fluid. And the collagen fibers hold it all together. So if you think of a very elaborate spider web, where in a spider web you would see spaces, in us you would see fluid, but extracellular fluid. So whatever you're transporting through that, whether it's lymph, whether it's steroids, whatever the substances might be, are all going through that pathway. So there's a lot of interesting implications for disease and disease processes there. And recently, and I'm sure you heard about this, Jonathan, about a year ago, there was that big paper about the interstitium.
Yeah.
The new organ.
Yeah.
Should we go there? Should we?
Yeah, I was going to ask you about it anyways.
Okay, so let's go there. So those of you who are listening at home or watching at home, this is stuff that didn't get in my book because this came out after my book came out. So this is like some of the stuff that'll be in the next edition, probably in 2022. So there is in classic histology, which is the study of tissue, generally microscopic, there are these holes in the specimens that they always get that were considered to be tear artifacts. So you go to get the biopsy, and they take the biopsy out, and they can't help but damage some of the tissue, and that leaves a little hole that they call a tear artifact. And what that represents is in the textbooks where you see a thick wall of collagen. So let's just say we're taking a liver biopsy, and we know there's that liver tissue, and then there's a thick wall of collagen, and then there's the next level of tissue, another wall of collagen, an artery, a vein, and so on. That's the way it goes. And then they take that slice out like a piece of cake, and you have that little space that's a tear artifact. Well, what they discovered a little over a year ago was that space is not a tear artifact, because instead of taking a slice this way, they were able to look at it that way, compare the two, and they realized that what they thought was a tear artifact is actually a fluid-filled space, which we would refer to as the superficial fascia. Which, if you're into traditional Chinese medicine, you might refer to as the triple warmer meridian, and so on and so forth. And the liver pathologist, Neil Tice, he's the one who really put the nail on this one in terms of helping the people who took the imaging figure out what was really going on and say, yeah, all those old textbooks are wrong. This is not a solid wall of collagen. It's a fluid-filled space that has collagen in it, very similar to the pictures that Jean-Claude Guimberteau has been showing us for over a decade now. So what's really fascinating to me is that all these different ways of looking at the same thing and seeing something different may just come down to nomenclature and how we name them, but pretty much might be all the same thing.
Mm-hmm. That is amazing. And so, can we go on this thread of the TCM system and the meridians? Because I would.
Yeah, but you might have to guide me through it a little bit more, because I do have an acupuncturist that I go to regularly, but it's not a system that I'm fluent in. So I'm willing to go down this path if you'll kind of help guide me.
Well, it's more of a general question about, do you think that the meridians are running through fascial networks? I do.
And my acupuncturist, who is Chinese and fourth generation acupuncturist and an MD, from her perspective, what she does and what I do, her attitude is we're doing the same kind of work. We're just using different tools, but our overall goals are the same, even if we go about them differently, that we're working the same system. We're just working it using very, very different tools. There is, and I think it's in Jim Oshman's book, and I believe the research goes back to Helen Langevin, where they were able to use, and don't quote me on this, a fluorescent dye or some other kind of medium and actually track the pathway of one of the acupuncture meridians through the fascial network. But it was just, again, it was one of these really interesting pieces of research that they did one, because that was all they had the funding to do, but then nobody picked the ball and ran with it to try to do more, because in research world, it's like, well, okay, that's one, but what about all the other ones? And that was just one on one sample. Can we do that one on multiple samples and get the same results? Then we have consistency. But even the fact that you could do it on one, for me, is pretty mind-blowing, because it says that there's something there that correlates and would befit further exploration.
It almost sounds like the Primo Vascular system. Is this something that you've heard of? And that
yes,
you know?
That's something that I'm just beginning to learn about. I do think that there's a connection. Obviously, all of the capillaries are in the fascial network and responding to constrictions in the fascial network or lack of constrictions. And if you go all the way back to osteopathy, at the turn of the 19th century to the 20th century, and its founder, Andrew Taylor Still, earthquake, Andrew Taylor Still, he really thought that it was all about it was about alignment and fluid flow. And the better aligned you were, and I don't just mean, skeletal alignment, but all of what skeletal alignment implies in terms of soft tissue, that would improve fluid flow, and that would improve overall health. And the governor of all of that was the fascia. Now, how he figured that all out in the 1870s is still a mystery to a lot of people, but he got more things right than not.
Wow. Let's circle back to your book and talk, introduce the listeners to the Tensegrity system and this concept of Tensegrity.
Okay.
Tensegrity.
Thank you. It's funny because I had a chance to talk to the father of Tensegrity Kenneth Snelson, and he did not like that word. He said it sounded like a bad breakfast cereal. And whenever I am voice texting and I say tensegrity, it writes Tensegrity. So I totally get that. Tensegrity is a combination word of the words tension and integrity. So the implication is that there is a certain degree of tension that gives us the right amount of physical integrity. And these structures were first developed in the art world. They were called floating compression sculptures, because you had pieces, you had rods, and you had bars in these sculptures that were held together by a tensional framework of wires, but the bars themselves never touched. And it was the overall tension of these things that held them together. Now, one of the teachers of Kenneth Snelson, who developed these floating compression sculptures, was a guy named Buckminster Fuller. He was a futurist and had some very wide-ranging, big ideas on how to transform society in the world back in the 60s. He's best known as the father of the geodesic dome, which I think most of the viewers have probably seen. If you think of the Epcot Center in Walt Disney World, that's a classic geodesic dome structure. So what you've got is you've got a bunch of rods that are held together by the fabric around the rods and the wire around the rods, as opposed to a traditional frame design where you have to have lots of 2x4s and bracing and cross bracing. So in the tensegrity model, humans are much more based on that kind of structural idea. Obviously, square frame is based on a square frame. Tensegrity is based on a triangle model. So the thing about a triangle is when you put pressure on a three-dimensional triangle, a truss, it distributes that strain throughout the entire structure. Whereas in a square frame model, it can only distribute that strain as far as that structure can withstand. So if a tree falls on a house, the damage is going to be much more severe than if a tree falls on a geodesic dome, because there's an inherent springiness to a tensegrity structure that in a square frame structure, there is no springiness. And I mean, you do some pretty intense yoga. I've seen some pictures of you that I still can't quite describe in anatomical terms. And maybe you can help me do that later. And I don't, do you do martial arts at all?
No.
Okay, I don't know why I had that feeling. But if you think about the impacts, I mean, the first thing that they teach you how to do in martial arts, and the part I remember the best, is how to fall. Because you need to learn how to fall without injuring yourself, how to fall with a spring and with a bounce to minimize injury from that impact. And that's what gives us that inherent springiness, is the fascia working in congruence with the skeleton to create this biological tensegrity unit, which is sometimes referred to when dealing with humans as biotensegrity. So if you see biotensegrity, that's just the tensegrity idea applied to organic structures.
And that's relevant to, say, body work and what you do, because why? So you can work on, say, some aspect in the foot and affect somewhere else in the body and affect overall structural change that way.
Yes, you can. You know, a real easy way to frame that is, okay, so I'm sitting in front of my computer, and if my ergonomics are bad and I'm like this all day long and my shoulders are coming in, and I do this all the time, and I don't ever take a break and I don't stretch, somewhere within 6 to 9 months to a year and a half, my collagen network is going to reorganize around this shape, and I'm going to have really tight shoulders. And I'm going to come to somebody like me complaining about my shoulders, but the problem is going to lie more with the excess collagen buildup distorting my tensegrity from the front. If I pull on my jacket hard enough, I can feel it in the back of my neck, but the pull is coming from the lapels. Okay? But it can very easily get more complicated than that. I'm in Minneapolis right now. I actually came out here to visit with an HUP, a highly unusual patient, who could not travel to come see me in Pittsburgh, but it was so potentially interesting that I decided it was worth coming out here to see what we could do. And I was working on the knee ligaments. This just happened a few hours ago. And this is a person who is got a medical background, very in touch with their body, very in touch with the way their body feels and how they respond to physical sensation. I'm working in between the ligaments that cross the knee joint. When there's a pop, didn't come from the knee, it came from the shoulder joint on the same side. Something went clunk and went back to a better place. And that one I'm still trying to figure out. So that's an even crazier version of this idea of tensegrity. But the body works more that way than like a system of levers and pulleys and hinges. Those are good models, but it's not the whole story.
Yeah. It's fascinating when you talk about the collagen reorganizing itself based on movement patterns.
Mm-hmm.
It makes sense, but it's not something that we conventionally think of. But it's almost making me think of neuroplasticity, where you can create a habit, you can create a behavior, a new one, and it's the repetition of that which will reorganize neurons in a way to keep it sort of locked into memory. So you can kind of, and same thing with neuronal movement patterns is kind of the same thing. And so it's almost like they're both integrated with one another.
Mm-hmm. Yeah, good segue, man. I absolutely agree with that. What fires together wires together, and that works in the musculoskeletal body as well as in the brain. And that's why I think it's important. I am more a proponent of what I call dynamic fascial technique. And by that, I mean there's active movement on the part of the person who is receiving the therapy. You can do a lot of beautiful work passively, but I don't think you engage the opportunity to begin to reprogram things on a level of neuroplasticity. So I can find areas that are stuck and I can go in there with a mechanical intervention. But if I can get you to move and pay attention and work with that mechanical intervention, then I'm talking to the nervous system. Then I've got the brain involved. And then I get you up off the table and say, okay, go pick up your backpack again and tell me what you feel this time. And you go, oh, wait, it's different. Okay, how's it different? What did you feel? And sometimes people are very specific. They might be, oh, now I feel like a pull over here now that I didn't notice before. Or they might say, I don't know, but it feels better. And I don't know is okay, as long as we're moving in that direction of better. So that begins to change things, on all levels of the body.
Mm-hmm.
So that's my preferred way to work.
Yeah, it makes a lot of sense. And reading your book has got me thinking about, is I do a lot of, this in a way is interoception. In a way, it's interoception. And so I'm thinking, wow, how much are we feeling through the fascia that is eventually making it to the sensory system, the sensory neurons, and how much of that is just the neurons that we're sensing, we'll say like in the gut, for example, and working off a gut feeling or intuition that some people kind of feel something going, like in a decision-making process. They're feeling something in the gut. I'm wondering, wow, how much of the fascia is involved in that process of sensory perception, and how much is just purely the nervous system that is giving us the feedback.
Okay, and likewise, if your fascial system is compromised, how much is that signal being compromised?
Ooh, yeah.
Right?
Yeah.
And I see that, and this is, I almost want to call them sensory processing disorders. What might be a grain of sand in our shoe feels like excuse me, or more like a pebble in our shoe that's annoying our foot, to them feels like somebody's jabbing them with a knife, and they can't disassociate from that feeling. It overwhelms them so much that they've got to deal with that right now. They have no voluntary control almost over that. Like they're turned up permanently to 11 in some areas. And I do think some people are naturally more interoceptive than others, but I also think it's something like anything else, that if you pay attention to it, it can grow and it can change. But by the same token, the gut feeling idea is, that's getting into the enteric nervous system, which has a crossover with the cerebral nervous system. And, feelings are good, but sometimes they can be inaccurate too. They can be influenced, by other factors that may not have anything to do with the fascial network at all. But yeah, are they all related in some fascia? Some fascia? Are they all related in some fascia? Yeah, David talks, take 3. Are they all related in some fashion? Yeah, I really think that they are. I work in an integrative medicine center, and one of the other names for something like that is what they call mind-body medicine. Of course, you and I would call it body-mind medicine, right? Because that's our way of getting into it. And I really think the fascia is the connector between the body and the mind. I absolutely believe that. And I think if you aggregately look at the science, it points in that direction. We can't run a conclusive experiment that proves it, but aggregately, it's pointing towards what's known in science as an emergent truth. That things are, all these little compasses in all these different areas are all lining up and pointing to the same area. So that's definitely an area that we need more research and exploration in.
Yeah, on this thread of fascia and nervous system integration, specifically in the brain, I love that you go into the glia in the brain, because not many people want to pay attention to the stuff that's not neurons, and it's like it's got a lot of importance. It's got a lot of importance. And so, can you tell listeners a little bit about the brain from that perspective?
Sure. Now, I'm curious, what did you know about the glia before you got into that part of the book?
Well, I worked with, for about 2 years, a neurofeedback system that claimed that it worked on the glia.
Huh.
It did not work on a neuronal level. And so the neurofeedback that was occurring, this was a very, very slow waves. They were 0.1 hertz and lower, 0.01, 0.001 hertz, extremely long wavelengths of biofeedback into the brain that were having incredible results for mostly with people that are on this autism spectrum. And the founders of this system, it's the most used neurofeedback system in the world, like unified system in the world. But it is pretty much built out of clinical practice. There's not a whole lot of research behind it. And so they are a little bit ostracized within the neurofeedback community because of that, but they still get results, even though no one can really explain what's going on. But the founder talks a lot about how it is affecting the glia.
Okay. Sorry about that. I keep turning my messages off, but they keep coming back at me anyway. So I apologize for the pinging noise. We live in a technological age. Thank you for that, Jonathan. That is fascinating. And maybe in the show notes or later, I need to know what this system is. And if you can put me in touch with these people, I'd love to add that to my database of things in my research on glia.
Yeah.
So, glia are a class of brain cell that were once described as the fascia of the brain. So that's why I was like, oh, I got to look at what that's about. And you realize that calling them fascia of the brain is really more of an analogy than a reality. But that just made me want to dig deeper. So the the glia are smaller than the neurons and more abundant than the neurons. And at the time that the staining techniques were invented, kind of like the staining techniques I talked about earlier with the interstitium and the histological samples, um, they began to image these structures, and the glia were sort of deemed to not be as important as the neurons. The neurons were bigger, they were easier to see. Some people would say these scientists were men, so they had a bias towards, hey, if it's bigger, it must be more important. Just saying. But there was competition. And at the end of the day, the neuron doctrine won the competition of the best theory. And modern neuroscience is predicated on the neuron doctrine. But it's not the whole story. Just like in orthopedic medicine, joints are not the whole story. The glia outnumber the neurons about 9-1. And they're responsible for care and maintenance to the neurons. But the big deal was it was discovered in, I want to say, 2004, that they actually communicate to each other via chemical messages. They were just kind of thought to not be that involved with things. Kind of like the fascia. They were packing peanuts, and they had some custodial mopping up duties. But no, the glia communicate to each other. The glia regulate neuronal activity. The glia also can be the cause of chronic inflammation in areas of the brain that are linked to chronic inflammation in areas of the body. And that's something that's just come out in the last 2 years that I've been exposed to. So again, that's, to me, another good reason to engage the neuroplasticity, clinically speaking, to get that body-brain connection going. To maybe if we can get the inflammation cleared up here and talk to the brain while we're talking to the body, maybe we can affect the inflammation up there. And moreover, there are papers now saying it's not about muscle memory, it's about glial memory. The glia are responsible for muscle memory. The glia actually regulate the production of ATP, which actually affects breathing. This is on the autonomic level. They're very involved in myriad aspects of neuronal function that we've ignored for years. And this is not unusual in science. We find something new, and a bunch of people go running over there to find out as much about it as they can, and other stuff falls by the wayside and gets ignored. And then it swings over in the other direction. And then hopefully we come somewhere back into the middle with a better understanding of what we're actually dealing with in the first place. I also want to add, I've got several papers I'm reading now, Jonathan, that people are creating these mathematical models that are saying the glia to neuron ratio is not 9-1, it's 1-1. Which really puts the kibosh on a lot of my ideas, but I'm not entirely convinced of the accuracies of these mathematical models. And I haven't talked to a lot of glia scientists who are as enamored of them either. And I don't completely understand how they're being generated. But then that throws light. Now, this is something else for the listeners. As you go up the food chain, the glia to neuron ratio always gets larger. So in a rat, you might have a 1-to-1 glia to neuron ratio. In a dog, you might have a 3 or 4-to-1 glia to neuron ratio. And in humans, you have this 9-to-1 glia ratio. They also did this crazy experiment where they injected human glia into rats, and the rats got smarter. That's really freaky stuff. And I've written to the people who did that experiment and said, what happened to the rats after the experiment was done? And I tried repeatedly to get an answer. And I think the answer is the rats took over the lab and they didn't want to write back and tell me. I never got a response to that one.
A large part, or maybe the entirety, please tell us, of the immune system in the brain is the glia. Is that correct?
That is correct.
Does that exist in the peripheral system as well, in the peripheral nervous system? How much, or in other words, how much does the fascia interact with the immune system in the rest of the body, if at all?
Well, there is one glial cell that is in the peripheral nervous system. That's the microglia, which also has a very strong immune function. And they're hanging out in the periphery, which gives them a chance to interact with the fascial system. And the fascial system actually has a direct connection via the fascia of the suboccipital muscles, which connect the base of the skull to the spinous processes of C1 and C2, directly into the dural tube. And they've done stainings that show the sensory nerves, the fascial mechanoreceptors, also being part of that chain. And that feeds into the dural tube, which feeds into the dura mater, which is the fascial covering around the brain. So it seems to me there's some potential for glia fascial interaction there. And a colleague just sent me a paper on these fluid pathways that run through the brain. That I mean, literally just sent this to me the other day. That opens up whole new avenues of this idea of the interrelatedness of that system. But again, I just cracked that paper. So if we do a part 2, I'll send it to you when we're done. I think you'll really, really find this fascinating, and I can send you her information also.
Wow, this is exciting.
Yeah, I know it's like this stuff that I'm just like, oh, I just skimmed the surface of it, so let me talk about it. But I can call it up here in a minute.
Is just, I don't know if this is fresh in your memory or not, but is it involving the cerebral spinal fluid at all, or is that a separate fluid system?
Well, there's some people that think that the cerebrospinal fluid is not necessarily just in the spinal cord. Here we go. There are direct vascular channels that connect the bone marrow of the skull and the brain surface. And it's these vascular channels that enable cell migration throughout the brain. So that's what this paper is showing in a nutshell. And that feeds back to what you were talking about earlier with the, not, I'm going to say microcirculation, but that gets it wrong. The
Primo vascular system.
Yes. Yeah. What these imaging shows is this vascular system in the brain from the marrow through into the dura, which seems to me like part of that primo vascular system. That's functioning in the brain. Certainly the cerebrospinal fluid is circulating through that primo vascular system as well. So, you know, after thousands of years of these ancient cultures saying it's all connected, to me what's really exciting is that we're actually uncovering how it's all connected. It still doesn't explain how it all works. But we're showing, it is all connected, and we need to take these things in as a whole when we're dealing with ourselves and our bodies.
I would love to.
You're getting really out there, man.
I'd love to maybe go into emotions now, and I bring this up because, as you're well aware, if one is doing body work, even if you don't talk about emotions, if you're working on an area of the body that may have experienced physical trauma, a lot of times the person that is being worked on will talk about feeling emotional when they're getting the work. Like the emotions are erupting as the work is going on. And so I would love to hear your perspective on emotions as it relates to fascia.
Okay. Have you ever had that experience, Jonathan?
Yeah, I have.
Okay. What was it like?
It's it's like remembering, kind of. It's like remembering.
Yeah. That's one of the things that drew me to this work in the first place. That's one of the things that drew me into studying neuroplasticity and the glial cell and the glial system. And there's this collagen, or I should say fascia in general, so I'm talking about the collagen and the fluid, um, has on a molecular level a liquid crystalline structure. That means it's a very ordered, very regular structure. Okay, so things with liquid crystalline structures are very reliable for the storage and exchange of energy and information. So right now, you and I are talking to each other via these cameras, but we're looking at each other on a liquid crystalline screen. Okay, so they can, through electrical charges, be manipulated. Um, I obviously can't prove it, but it's one of the areas that interests me strongly, is that, you know, we're not entirely certain where memory resides in the brain, are we? So I wonder if memory isn't located throughout the body. So to use the digital world metaphor, we have our hardware, but we have our software and our apps. And that could be in the realm of the fascia because it has that liquid crystal storage potential. And why, when I get touched on my anterior scalene, which I write about in chapter 5 of the book, did I go back to when I was 4 years old and I almost got strangled. Now, I had psychologically processed that years ago. But whoa, there was a very vivid recall of that when I was working with somebody who I trusted. I've had my scalene worked on more than a few times at that point, but all of a sudden, boom, there was a piece of that. You know, yes, I knew where I was in the room, I knew where I was in time and space, but there's that incredible vividness of instant recall of that movement. And and she felt me stiffen, and I said, "Don't stop." I said, "Just keep going. I'm fine. I don't want that there anymore." Now, did I have a big emotional breakdown from that? No. But it was very intriguing to me that there was a piece of that seemingly still stored in the fascia of my anterior scalene 40 odd years later. So why would that be hardwired unless there is some aspect of memory that's physical? I mean, of course, aspect of memory is physical. You know, do you play a musical instrument?
Yeah.
Okay, I do too. When you learn that piece and you really have it down, you can play it without having to think about what your fingers are going to do. There is that physical memory. Some people call it muscle memory. Of course, I want to call it fascial memory because that's my bias and I admit it. But that seems to make more sense to me because to me, fascia seems like a much more intelligent tissue than the muscle. And that really, I'm a horrible person, you know? It's like the muscle was Rocky and the fascia's Burgess Meredith. Okay, Rocky, you're going to go into the ring. Here's what you're going to do. Here's how you're going to play it up, okay? You know? But that tends to be my bias, and I freely admit that bias. And if somebody can prove to me differently, I'm happy to change my bias.
In a situation where someone has some kind of, let's say, adhesions, they've got some scar tissue in a certain area, does that mean that that particular tissue has got more fiber and less of this fluid? Can you say that?
It can mean a couple of things. I thought you were going to ask me if it meant that it was an emotional problem. So we kind of took a left turn there. Well, it could be that they have more fiber. It also could mean that through lack of motion, one of the other important fluids in the fascial system is hyaluronin, which is more colloquially known as hyaluronic acid. Which is a lubricant. It helps muscles slide on each other. It's particularly abundant in the sliding surfaces between muscles and also between the superficial and the deep layer. When that is not sufficiently moved, it gets thicker and sludgier. So it could be that there's an thickening of the collagen, but it could also be that there is let's prevent a new word, a gluifying. There is a densification of that hyaluronan, or a combination of the two. In my experience, clinically, I would say that the newer it is, it's just about 3 months ago this started, and I don't know where it came from, it's more likely to be a stronger hyaluronan thickening component and less of a collagen component. If it's 9 months to a year and a half to multiple years, it's going to be a combination of both. And if we, and that's just my informed speculation from working on hundreds and thousands of people for 20 years.
It's not exactly left turn, and here's why. I was asking about the composition, or what you thought the composition was, because it is my mind's sort of going reductive right now, wondering, well, where would that, if there was memory storage, would it be in the fluid or would it be in the fiber? If you could even do that, because there's work by like Masaru Emoto, who did these memory imprints on water. You may or may not be familiar with this, where he
I am, and the thing that bothers me about Emoto is he never let people replicate his experiments. He never released his methods for other people to try and test to see if they got the same results. And that's, in science land, we call that pathological science. I'm not saying he made some really interesting pictures, but it might not be what he thought it was.
Yeah.
But are you familiar with Jerry Pollack's work?
Yeah.
Yeah. And that's, he's flown in and out of the fascia world. Some people really embrace his ideas. Others are highly more skeptical. I'm somewhere in the middle. I think he's really onto something. At the same time, it's been pointed out to me that he's observed water do some very interesting things in highly specific conditions that may not replicate the conditions inside of us. But I think Jerry asks a lot of really important questions about water that challenge our knowledge of what we really think water is and what it can do. And that falls back into these vascular channels in the brain, and the idea of again, it all coming down to fluid flow. So, I know that there's Candace Pert's molecules of emotion, May Wanho's The Rainbow and the Worm, and they all get into this idea of water and storage capacity in memory. I mean, that's really out there stuff, but and traditionally, the more out there you are, the more grounded in science you have to be to begin to gain some of that acceptance. It's like quoting from somebody named Anonymous and saying it's a truth. Well, you could have made that yourself. Well, am I making any sense, man? Reel me in.
No, absolutely. From your vantage now, what is, from a fascia maintenance, fascia optimization, personal practice standpoint, what are some best practices here just to keep the fascia healthy? How to move, what to eat, what to drink, that kind of thing.
Well, vitamin C is absolutely essential for collagen production. So be sure you're getting enough vitamin C, however you're doing it. Okay. Obviously, water is important. Drink when you're thirsty, because you can drink too much water and overhydrate, and that kind of slows things down too. Okay. And an interesting notion in terms of hydration and keeping things fluid and moving is maybe you should drink your water before your body work or before you do yoga, so you've got something to work with and not just replenish it afterwards. Okay, so part of the fluid component of fascia is a slightly thicker extracellular fluid. It's not like the water that we drink of as we think of it. And there's these structures called aggregans, which are kind of like spongy ferns that kind of work to absorb, squeeze, and let out water, absorb, squeeze, and let out water. So there's this idea that as we get, and of course I'm partial to getting good fascial body work, as we squeeze those sponges, whether through body work, through rolling, through yoga, or all of the above, we're exchanging water. So if we have water in the system when we're doing these things, we're going to get a better rate of return. I think the thing about fascia is that you can also overwork it. It's when enough is enough. So I had a very high achieving person in my practice once, love him to pieces. He climbed Mount Kilimanjaro for New Year's. I mean, you gotta love that, right? That's something, man. But he goes at things. So when he found out he had an IT band problem, he started foam rolling it for an hour a day. But that's him. That's how he goes at things. And I'm like, dude, don't you think that was a little over the top? But then again, this is a guy who climbed Mount Kilimanjaro. And he did that for 30 days and wondered why it didn't get better. So there is a turnover cycle when you're stimulating the collagen network. So, I'm here treating somebody. I'm going to go back and see them again tomorrow morning. And I might fine tune what we just did this afternoon, but I'm not going to spend a lot of time on what we did today. We need to move on from there because we've already treated that area. And that collagen needs time to recover and respond to the stimulation that it got. And that's usually a 36 to 48 hour cycle where we've stimulated the fibroblasts, which are the cells that produce collagen, and they are stimulated by mechanical signals, and they're also stimulated by direction. So yeah, right. Which is why, it's like if I do a yoga class and there's not enough twists in it, I walk out feeling very two-dimensional. Because I want a 3D workout, man. So if I've got somebody who's got their shoulders up around their ears, why would I have them on the table on their stomach and work up their back this way? No, I want to stimulate those fibroblasts in the underlying matrix in the direction that I think ideally their shoulders would like to be in. So if we overstimulate that, we're going to induce an inflammatory response, and we're not going to get the best result. So if we're doing fascial training, bounce is very essential to that. So if you're doing Uttanasana, and you kind of change the vectors a little bit and put a little bounce or a spring into it, that would be a very fascial way to approach Uttanasana. If you're doing a daily practice, I wouldn't do it every day. You won't be happy with the results. Because after somewhere between 36 and 48 hours, those same fibroblasts, instead of secreting an enzyme that starts to eat up the collagen in those areas that you want more movement, they're going to start secreting the collagen in the areas where you now want new collagen and more stability. So it's a both-and situation. Yes, you want to increase your flexibility, but you also want to increase your stability where you need it more. And that's a 4-day cycle. So you don't want to keep hitting that, or you're going to wind up having an even worse injury. So it's like, that felt great. I did that for a half hour. Let's do it for an hour tomorrow. Maybe not. It's like, you don't do, if you go to the gym, you don't do your lower body workout every day you go to the gym, do you? And that's just on the muscular level. That's not on the fascial level. So part of it is this, twice a week is plenty. And when I see a patient, I usually see them, if they're local to me, once a week, because that's just fine. But if they're a special needs case or we're only available for a limited amount, if I work intelligently and I take their capacity in consideration, you can actually get a lot done in a short period of time if you don't overdo it in certain areas.
Wow. I'm going to do a time check right here. Okay. Yeah. So
I hope this is good for you, man, because I know I'm really taking off on some things.
It is. It's amazing. Yeah. It's where I was hoping we would go. And I'm so glad that you're willing to go there.
Oh, good. Good.
Because a lot of people won't step out of their very specific trajectory that they're in. So I appreciate that.
Well, I got to tell you, I wrote the book I wrote the book. There's about 220 citations in the book in terms of references the scientific literature. So it was really important to me that I had that foundation and grounding. And I wrote it in a way that hopefully would make the reader ask even more questions, and maybe put the pieces together in new and different ways. And in conversation, I am so happy to do that, because that keeps me interested and keeps me stimulated, as long as it were clear that we're talking about correlation and speculation, and not something we absolutely can prove.
Before we, so I wanted to ask you about foods. You know, foods, if that other than vitamin C. But are you a believer in eating like hydrolyzed collagen peptides, or bovine collagen, or bone broth, or you know, this kind of thing to support?
Well, listen, Sonny, back in my day, it was all bone broth. Sorry, I'm 55, so sometimes I'm like, really? It's like, we always made broth by boiling chicken bones. You know what? I don't think it can be bad for you. And certainly, you know, I mean, my grandmother, when you were sick, she made chicken soup. How did she make it? She took a chicken and she took the bones and she made it that way. So grandma knew something. Grandma was more often right than she was wrong about things like that. So is there something to that? Probably. Does it improve our collagen network by taking collagen supplements? I haven't seen anything to convince me that it does.
Mm-hmm.
I haven't seen anything to convince me that it doesn't. I have been told by Antonio Stecco that taking hyaluronic acid supplements, he's not convinced to anything, and I'll take his word on that. I'm on the fence about collagen supplements, but you know what? If you feel good drinking bone broth and it makes you feel healthier and more fit, God love you. That's great. I wonder if maybe it's more helpful in people who have a collagen laxity issue. Myself, people who are hypotonic, people who have Ehlers-Danlos syndrome, people who are hyperflexible. You know, it might, but I haven't seen enough data to know one way or the other. And it's easy to make claims.
Well, we're going to put, for the listeners who want to get the book, Fascia, What It Is and Why It Matters, we have a discount coupon code here in the show notes, so you can reference that. Give us your websites, please, before we sign off.
Okay, so my practitioner website is my name, davidlesondak.com. We put that in the show notes. And I have another website that I just launched. It's still got some parts and pieces coming in, which is Fascia Matters, like my book, fasciamatters.health, www.fasciamatters.health. And that's got information about the book. It's got information about the classes that I'm teaching. I need to update my appearances. I'll be going to Poland in September, Korea and France in spring of 2020. And I'll be speaking at the British Fascia Symposium in May of next year. Anyway, but I'm very available for those kinds of events. And if you want to keep track of where I'm going, if you want to check out my blog, that's all on fasciamatters.health.